Hi, welcome to Database Management System. Hi, from this video we are going to learn about the mapping conceptual design into a logical design, or we can also call it as relational database design using ER2 relational mapping. So there are few steps we are going to learn then how to convert the given ER diagram to a relational mapping. So that following steps we are also calling it as an algorithm or procedure to convert the entity relation to a relational mapping algorithm. There are few steps are there. We will see the steps how we are converting ER to relational mapping algorithm. Step 1. In the step 1, so we are mapping a regular entity types. So in the step 2, we are mapping of a weak entity type. In the step 3, we are mapping of a binary 1:1 relation type. And in the next step, we are going to map a binary 1:n relationship types. And in the fifth step, we are converting or mapping of a binary M:(n) relationship types. And in the sixth step, we are mapping a multivalued attribute. And in the last step, we are mapping a N-ary relationship type. So to convert our given entity relationship diagram into a relational mapping. In the step 1, we are mapping regular entity types. Means, so for each regular entity type E in entity relationship schema creates a relation R that includes all the simple attributes of E. Means here we are selecting the strong entity type from the entity relationship diagram, that we are calling it as a relation R, and that relation R which includes attributes, those attributes we are calling it as a simple attributes of E. So that is a meaning of the regular entity type. Then after identifying the relation R and their simple attributes, we have to select one of the key attribute from that relation E as a primary key for R. That is, for example, so for a employee table, SSN will be one of the attribute for the relation employee, where that entity so will acts as a primary key for that relation R. If the chosen key of E is a composite, the set of simple attributes that will form it will together to form a primary key of a attribute R. For example, if whatever the attribute, if we are selected from that relation R as a primary key, if it is a composite attribute, then so that composite attributes all together will going to form a primary key. For example, so we have seen entity relationship diagram of a company database. So from that company database, we create the following relations like employee, department and project. In this relation schema, the corresponding to the regular entities in the ER diagram, where employee includes the SSN, department number includes the department table includes the department number, and project table includes the project number. These are the simple attribute of an relation R. These three attributes, SSN, department number and project number, are the primary keys for the relation employee, department and project, so which is as shown in the figure. You can see this figure will going to give a clear picture where strong entities such as employee, department and as well as project. So where this employee department and project will includes entity or attribute. That attribute we are calling it as an SSN, and projects includes project number, and department table includes the department number. You can see these three attributes will act as a primary key for this table or a relation. This particular figure will gives the clear picture of a company entity relationship diagram will be converted into a ER schema, and then from that ER into a relational schema manner. It includes employee, department, department location, project, works on, and dependent. These are all we are calling it as an entity types. So from this entity types we are creating a relation company. Each entity type is having a different set of attributes. From that different set of attributes, one attribute will act as a primary key attribute. For example, in the employee table, SSN will be the primary key. Similarly, in the department table, department number will be the primary key. So, and as well as in the project table, the project number will act as a primary key of that particular table. Then, so where works on, dependent, department locations are there, that are all so not as strong entities. They might be call it as weak entity or else relationship types. So by looking into this schema diagram, we are moving to the next step, that is step 2, mapping of weak entity type. From that figure, that is company database ER diagram, we need to identify which are all strong entities are there and which are all entities are a weak entity type. The entity which does not have a key attributes of its own, those entity we are calling it as a weak entity type. So for those entity types, we have to identify the owner entity type. To identify that, we are using a mapping of weak entity type step 2 concept. So here the for each weak entity type W in entity relationship schema with owner entity type, we are identifying the weak entity type. So means which will going to create a relation R, and also it includes a simple attribute or a simple components of composite attributes of W as a attributes of R. So and also it includes a foreign key attributes of R, the primary key attributes of the relation S that corresponds to the owner entity type. Here, so in the weak entity type there is no any key concepts. Therefore, the primary key entity of owner will act as a foreign key entity type or attribute for the corresponding weak entity type. The primary key of R is the combination of the primary keys of the owner and the partial key of the weak entity type W, if any. In this case, for this weak entity type, we are creating a key attribute by the combination of the owner entity primary key and as well as one of the entity which is selected by the weak entity type as a partial key. So combination of these two, we are calling it as a primary key for that weak entity type. For example, so from that company database, we have seen create the relation dependent in this step to corresponds to the weak entity type dependent. That is, so dependent is an entity type which we are calling it as a weak entity type, which does not have a key attribute. Okay, so this will includes the primary key SSN of employee relation, where employee relation will act as a owner and their primary key SSN will act as a foreign key attribute for this weak entity type, that is dependent, with a renamed as ESSN. The primary key of this dependent relation is the combination of ESSN, dependent name, because dependent name is the partial key of the dependent table. Both ESSN and dependent name together will going to form a primary key for this dependent table, that is weak entity table. By using this kind of technique or a method, we are mapping a weak entity type. Next step is step 3, mapping of binary 1:1 relationship types. In this mapping of binary relation 1:1 relationship type is nothing but whenever there is a relationship type R and the two entities are participating in this relationship type R, when two entities are participating in the relationship type R, then we are calling it as a binary relationship type. Then we have to identify the cardinality ratio of this relationship type R. What type of relation entity is participating in this relationship type, whether it is the total participation or partial participation, or else we can also call it as minimum participation or maximum participation or existent participation. To map this kind of relation, that is 1:1, we are calling it as cardinality ratio constraint. So here for each binary 1:1 relationship type R in entity relationship schema, we are identifying the relations, that is which will be participating in this relation R, those entity type, that is S and T, that corresponds to entity type where they are participating in the relation R. Basically there are three possible approaches are there. So how these entities are participating in the relation R, and how we will be identifying whether the participation constraint is 1:1 or not. The first possible approach is foreign key approach. In this foreign key approach, so we have to choose one of the relation, say either S or T, and we have to include one attribute as a foreign key in S. The primary key of T, that where so the one of the attribute, that is primary key attribute of the entity type T, will be participating the same attribute in the relation say S or entity type S, where it acts as a foreign key constraint. It is better to choose an entity type with the total participation in relation R in the role of S. Whenever we are specifying so a relationship type R, so we have to specify the total participation constraint when we are choosing entity type which will be participating in the relation R, that is S, where S is acts having a foreign key constraint, which entity type is having a foreign key constraint. So they need to be a total participation in the relationship type R. For example, you can see where 1:1 relation, that is from the company database or entity relationship diagram, where managers is the relationship type, which is mapped by choosing the participation entity type, that is department, okay, to serve in the role of S, because it is participation in the manager's relationship type is total participation. Why? Because the department number is there, the department number is acts as the foreign key constraint in the employee table, okay. Therefore whenever it is acts or serves a role of S, so then there should be a total participation in the relation. Then second approach or possible approach is merged relation option. So merged relation option is nothing but when two entity types are merging together and the relationship into a single relationship, then we are calling it as a merged relationship option. So this may be the approach. So when we can merge these two entity types means when both are participating it as a total participation in the relationship type, then only we can merge the two relations in that cases. That is, we can treat it as a 1:1 relationship type is only possible whenever we are merging the two entity types and the relationship into a single relation. So that is a second approach or a possible approach where we can specify 1:1 mapping between the two entity types. Then third possible approach where cross reference or relation option. This is the third alternative approach where we are going to set up the third relation, that is R, for the purpose of cross referencing the primary keys of the two relations S and T representing the entity types. This is the third option where if you are cross referencing your primary keys for the two relations like S and T, so where they are representing it as a entity types, so in that case, so where R can be represented by using a 1:1 binary mapping. Next step is step 4, mapping of binary 1:n relationship types. Under this 1:n binary relationship type, we have to identify what is the participation constraint of two entity types which are participating in the relationship type R. So if based on that we have to specify whether the participation constraint is 1:n or 1:1. So based on the relationship type and as well as participating entity types. So now we will see the explanation for each regular binary 1:n relationship type R. Identify the relation S that represents the participating entity type at the n side of the relationship type. Means, so there are two entity types are there or relations are there. They are participating in the relation R where S includes the foreign key constraint, and one more relationship type is there, that is T, which includes the primary key, where so foreign key will entity type is participating in this relationship type R. We have to represent by using a n side of a relationship type. That is the meaning of. And one more side is there where T relation is participating in this relation, that is by using a primary key constraint, so that you can represent it by using a 1:n manner. So here it includes the foreign key in S, then the primary key of a relation T that represents the other entity type participating in R. It includes any simple attributes of the 1:n relation type as the attribute of S. So I already clearly mentioned that. So when we are talking about the two relation S and T, S is having a foreign key attribute and T is having a primary key attribute. Both are participating in the relationship type R, where entity type includes the foreign key constraint. That should be a total participation in the relationship type. Therefore, we have to represent it as a n side relationship type. And one more side where it includes the foreign primary key constraint, that is participating in this relationship type, that will be represented by using a 1. So that is the meaning of the mapping of binary 1:n relationship type. So here, so from the company database example, you can see the works for controls and supervision in the figure. These three are the relationship type, where so entity types are participating in this relationship type. For example, so when we are considering the works for, we include the primary key, that is department number, so from the department table relation, as the foreign key in the employee table, where employee table includes the D number. So here, so the total participation will comes from the employee and partial participation will comes from the department. Therefore, wherever it is a total participation, then our maximum participation, then we have to represent it by using a n-side relationship type. Then partial participation or so minimum participation, we can represent it by using a 1. So that is what we are calling it as a 1:n relationship type. So our mapping of a binary 1:n relationship type. Next step is step 5, mapping of binary m::n relationship type. So in this mapping of binary m::n relationship type, when two relationship types are participating in a relation R, where we have to specify the constraints, that is cardinality ratio constraints, based on the participation of either S entity type or R entity type. Based on that, so we are specifying the relationship type R, which is m::n manner. So here, the for each regular binary m::n relationship type R, we'll going to create a new relation S to represent a R. So which includes as a foreign key attribute in S as the primary key of the relation that represents the participating entity types. Their combination will going to form the primary key of S. So for example, I will tell you. So let us consider there is a works on relationship type in company database. In the ER diagram, so where it includes the two entity types which are participating in this relationship type, that is works on. The primary key of the project and the foreign key of the employee, that is project and as well as employee, these two relations are included so in this relationship type, that is works on. The primary key of the project and as well as the employee relation are included as a foreign key in the works on, and it is renamed as a project number and as well as ESSN respectively. So that is one example where I have specified when these two relationship types are or entity types are participating in a relationship type R, in that case the relationship will be included, that is m::n manner, or converted into m::n mapping manner. Also includes any simple attributes of the m::n relationship type as an attribute of S. Example, what I have told, the same thing, the m::n relationship type, that is consider a works on relationship type. So from the entity relationship diagram, where it is mapped by creating a relation that is works on in the relational database schema. So this relational database schema includes the key attribute, that is project number and as well as ESSN. This is a combination of two entity types primary key attributes combined together to make a key attribute of the relationship type, that is works on. The primary keys of the project and the employee relations are included as a foreign key in the works on relation, and it is renamed as project number and SSN respectively. And you can go with the one more example, that is attribute hours is there. This hour attribute is included for the works on table. So that is works on relationship type is having an attribute, that is hours. So it which is represents the hours attribute of a relationship type. The primary key of the works on relation is nothing but it is the combination of project number and as well as ESSN number. The project number is the primary key of the project table. So employee table is having a ESSN is the primary key. Both combined together will form will going to identify the hers attribute of the relationship type, that is walks on. So this is how, so these project and as well as employees both are having a relationship type, that is R. So is total dependency is or constraint is M is to N manner. The next step is step 6, that is mapping of multi-valued attributes. The mapping of multi-valued attributes are nothing but, so whenever we want to map a multi-valued attribute, like for example, you can see department location, the department location which is a relation which is created, so where it includes the department number and as well as the department table relation, that is department number and department location, both together will form a primary key for that department location. This is what we are calling it as a multi-valued attribute will form a relation where it is identified by using this primary key, that is a combination of the two or more attribute values. So that is what we are calling it as a multi-valued attribute. So for each multi-valued attribute, that is A is the multi-valued attribute, create a new relation, that is R. Okay, so how it will going to create a new relation R means this relation R will going to include an attribute that corresponds to multi-valued attribute A plus the primary key attribute of the K as a foreign key in R, that is one more attribute will be there, that is K attribute, which will act as a foreign key constraints for this relation R, that represents the entity type of relationship type that has A as an attribute. The primary key of R is the combination of A and K, that is attribute A and as well as attribute K, both together will form a primary key for relation R. If the multi-valued attribute is composite, we include its a simple component. For example, the relation department location is created. So in this relation, that is department location, the attribute department location represents the multi-valued attribute. Locations of the department, while department number as the foreign key, which will going to represent the primary key of the department relation, where if I write both together, that is department and number and as well as department location. So why? Because department location is the multi-valued attribute, but department number is not a multi-valued attribute. When we will combine together, then so by using that primary key or foreign key constraint, we can refer the department location. That is primary key of R is the combination of these two, that is department number and as well as department location. Next is last step, step 7, that is mapping of N-ary relationship type. So in this N-ary relationship type, when we are talking about still step 6, we are talking about the binary relationship type. Now we are talking about the N-ary relationship type, means when two or more number of entity sets are participating in a relationship type R, then we are calling it as a N-ary relationship type, or so ternary relationship type. So for this kind of relationship type, how we have to convert ER diagram to a or a relationship diagram into a mapping or relationship mapping. So for each N-ary relationship type R, where N is nothing but so entity types, if more than two entities types are participating in the relationship type, then we are calling it as a N-ary relationship type, which will going to create a new relationship, that is S, 2 represents the R. Okay, so here what happens, it will going to include the foreign key attribute in S, the primary key of the relation that represents the participating entity type. And also it includes the any simple attributes of the N-ary relationship type or a simple component of the composite attribute also as an attribute of S. For example, you can see in the example how this N-ary or greater than 2 relationship types are mapping, and as well as how we are representing the primary key and as well as foreign key constraints for this relationship type. So the relationship type supply in the entity relationship diagram, so you can see in the next slide. So based on that, I will going to explain here. This can be mapped to a relation supply shown in the relational schema whose primary key is the combination of the 3 foreign keys. For example, you can see here S name is there, part number is there, and project name is there. So these 3 combination of primary key will form a foreign key for this supply relation. So here from this diagram you can see this is the ternary relationship type where supply is the relationship where it includes the 3 entity types. One is supplier, and second one is part, and the third one is project, where project will be having a primary key attribute, that is project name, and supplier is having a primary key attribute, that is supplier name. Then part will also have a part name number. To identify this ternary relationship type, we need to map this quantity attribute. To identify this quantity attribute, we required these 3 attribute values. The combination of these 3 attributes will identify the quantity attribute value. Unless and until if any one of the attribute is missing, then it's not possible to identify the value of the quantity relationship type. So therefore, so to identify this supply in the relational schema, so we need a combination of these 3 attribute values, that is S name, project name, and part number. If S name, project name, and part number will act as a foreign key constraints for the supply table, that is to identify the attribute value of quantity. This is how all the steps we are converting from the entity relationship diagram into a relational mapping.